Howdy, my name is Jesus Martinez, and I'm going to be going over the comprehensive assignment number 2. To start off with the first equation, the answer is NO2 plus 2O2 plus NO plus O equals the product of 3NO2. And this is because in the first equation, you get the product 2NO, and that cancels on the next step. So you immediately cancel those, and that leads you to not having it in the overall reaction. The N2 gets passed down, and then you count the oxygens, O2s, and you end up getting 3 in the reactant side and 1 in the product side, leading to only having 1. Leading to subtracting 1 on both sides and only having 2 on the reactant side. Next, the NO gets passed down, and the oxygen also gets passed down to the reactant side. And what's left is actually the 3 NO2s, which end up getting in the product side. The intermediates are only NO and O3, and this is because NO gets produced in the first step and subtracted in the second step, and the O3 which gets produced in the third step and gets subtracted in the fourth step. And this is also why it's not included in the overall reaction, and there are no catalysts. Next, for the overall enthalpy, you add up all the enthalpies and you end up getting a product of negative 239.9 kilojoules. For number 4, I couldn't really draw it out. I was trying to figure out, and I couldn't really get it to draw out. But if you had to imagine it, it's the reactants and the initial reactants, and there's 4 different steps because of the 4 different steps make the 4 different sections, and each one have like a little bump. But saying because EA2 is the largest, the second one has the largest and tallest bump, which makes it actually be the slowest reaction, and it's actually an exothermic reaction. So it ends up having imagine the reactants up here. At the end, you're gonna have the ending being lower than the reactants, or lower than the initial. For step number 5, which step is the rate determining step? As I said before, step 2 is the slowest one since it has the largest activation energy, meaning it's the slowest to go through, meaning it's the rate determining step. And then for number 6, it gives you that the NO divided by T is -4. And if you actually use the equation that it states from step 2, is the equation as per that I put there to remember myself. And NO2 is actually used. There's actually 2 of them used. So that means to calculate the oxygen, you have to divide it by 2. So 4.0 divided by 2 is, or -4.0 divided by 2 is -2.0. And because that's in the reactants, it stays with the same sign, which is negative. And next, to calculate the products, it actually has the same 2, so we don't actually divide it by 2, but it is on the product side, so we changed up the signs, which is positive 4.0 m divided by s. And for number 7, the rate actually is the answer, K and then NO and O2, all with respect to the first order. And this is because to calculate the order of NO, you first find where O2 has the same molality, which is in experiment 1 and experiment 3. And since those are the same, you end up dividing the NOs, which is, imagine it, the 0.002 divided by 0.001, which gives you a value of 2. And then you do the rates, which is 22 divided by 11, which also gives you 2. And since they're both equal, it makes it be reactant order 1. And same thing goes for O2, but you just do the opposite. So you find when NO is equal, which is experiment 1 and experiment 2, and then you divide experiment 2, which is rate 2, divided by rate 1, which is 0.002 divided by 0.001, which gives you an answer of 2. And then same thing goes with the rate, 22 divided by 11 gives you an answer 2, and since they're both equal, it's reaction order 1. And then for number 8, the half cycle, or the half, what is it called? The half-life, I mean. The half-life is actually just like the formula, which is ln2 divided by k. And for number 9, to actually block the photochemical smog, it's best to reduce the NOx and the VOC emissions because they're extra, and also to lower the temperature because lowering the temperature actually slows down the reaction rate. And yeah, that should be it. Thank you so much.